Hello, this is Mrs. Ward, and I am going to go over the 4.7, 4.8 review worksheet, which covers the inverse trig functions and the application section of our chapter. So if you remember, when we're doing an inverse trig function, we have to limit our domain so that we have a one-to-one function so we can take the inverse. So these are the circles that Mrs. Kelm had. So when I do an inverse sine or tangent, all my answers have to come from the first quadrant or the fourth quadrant. And remember, for the fourth quadrant, I'm not doing 5 pi over 3. I'm going to use a negative pi over 3 because that fits my domain of negative pi over 2 to positive pi over 2. So I have to be in that domain. 5 pi over 3 is not less than pi over 2, so I can't use it. That's why I have to use a negative pi over 3. And then when I'm doing cosine, which I think it kind of is a little bit easier, I'm going to either put, if it's positive, I'm pulling from the first quadrant. If it's negative, I'm pulling from the second quadrant. The reason why we do that is because we have two quadrants that are adjacent to each other, so that range or that domain is a continuous domain. We're not skipping around. So when I do these, when I say the arc sine, sine inverse, I want to know when the sine is equal to 1/2. It's positive coming from the first quadrant, and that's going to just be pi over 6. The next one, when is the cosine equal to 0? Well, that's equal to 0 at pi over 2. Now remember, the cosine is equal to 0 two times. It's equal to 0 at pi over 2, and I'm looking at this. It's equal to 0 at pi over 2 and 3 pi over 2. But this 3 pi over 2 is not in this domain. That's why I'm only picking pi over 2. Okay, tangent, when is the tangent equal to 1? That's going to be when the cosine and sine are the same because it's sine over cosine, and that's going to be pi over 4. So this is the first one. Number 4 is the first one when we have a negative. So when is the sine equal to a negative square root of 3 over 2? I know it's going to be with a denominator of 3, so I'm going to write negative pi over 3. Has to come from the fourth quadrant. But I'm not going to write 5 pi over 3. I'm going to write negative pi over 3. When is our cosine equal to negative 1? And that happens at pi. When is the tangent equal to negative 1? Well, I know it's a denominator of 4, but it has to come from the fourth quadrant, so I'm going to write negative pi over 4. When is the arc sine equal to the square root of 3 over 2? That's going to be pi over 3. When is the arc cosine equal to 1? That is going to be at 0. And when is the arc tangent equal to a negative square root of 3? And that's, so I want the sine over the cosine. So that's going to be the square root of 3 over 2, and then the 1/2, so the 2's can simplify. This happens with a denominator of 3, but since it's negative, I'm going to write negative pi over 3. When is the arc sine equal to negative 1/2? I know it's a denominator of 6 from this one, but so I'm going to write negative pi over 6 because it has to come from the fourth quadrant. When is the cosine equal to a negative square root of 2 over 2? Remember, cosine is the only one that uses the second quadrant, and that's going to be 3 pi over 4. When is the arc tangent equal to the square root of 3? That's the same as this one right here, square root of 3, same one. So I know it's going to have a denominator of 3, but it's positive, so it's going to be pi over 3. When is the secant equal to 2? Well, that's when the cosine is equal to 1/2. It's going to have a denominator of 3. It's positive, so I'm going to write pi over 3. When is the arc secant equal to a negative square root of 2, which means the reciprocal would be 1 over negative square root of 2. Rationalize, and that's where I get that square root of 2 over 2, negative. And that was the sine. So the sine comes from the fourth quadrant, so I'm going to write negative pi over 4. When is the cotangent equal to a positive 1? Again, the cosine over the sine, they have to be the same, so that's going to be positive pi over 4. The secant is a reciprocal of cosine, so the cosine is going to equal negative square root of 2 over 2. That's coming from the second quadrant, so that's going to be 3 pi over 4. Cosecant equal to negative 1. With cosecant is the reciprocal of sine, which means the sine is also equal to negative 1, and that's going to happen at negative pi over 2. And then remember, not 3 pi over 2, has to be between negative pi over 2 and pi over 2. I should put equal signs there. And then secant is a reciprocal of cosine. So the cosine is the square root of 3 over 2. So that's going to be pi over 6. And those are the first 18. That wasn't too bad. Okay, these ones are doing two things. So I like to do the inside and then the outside. So I'm doing, please excuse my Darren tally. I'm going to work with the inside then the outside. So this, I'm going to keep the arc sine. The sine of pi over 3 is going to be the square root of 3 over 2. And then this is asking when is the sine equal to the square root of 3 over 2. And that's just going to be pi over 3. Since they're inverses, these two will cancel each other out as long as this number is in the domain. So the arc cosine, when is the cosine equal to 1/2? And you're going to say that happens at pi over 3, and that's asking for the cosine of pi over 3, which will be 1/2. Again, they're inverses of each other, so they will simplify. When is the tangent equal to, what is the tangent of pi over 4? That's going to be 1. The arc tangent, when is the tangent equal to 1? That's going to be pi over 4. Again, inverses, so they cancel each other out. Here is where you get into problems, though, is they are inverses of each other, but because this is not in the domain, they're not just going to simply cancel each other out. I'm going to ask myself, what is the sine of 5 pi over 6? And you're going to say, well, that's 1/2. And then I'm going to do the arc sine, so when is the sine equal to 1/2? Because of that restricted domain, the answer is going to be pi over 6. So make sure you watch out for that. The next one. When is the cosine equal to negative square root of 3 over 2? And that's going to be 5 pi over 6. And what is the cosine of 5 pi over 6? That's going to be negative square root of 3 over 2. When is the tangent equal to -1? Oh, yes, that's going to be negative pi over 4. And then the tangent of negative pi over 4 is going to be -1. Again, they're inverses, they cross each other out. The next one, what is the cosine of 3 pi over 2? That's going to be 0. And when is the cosine equal to 0? Well, that you're going to have to say pi over 2 because this 3 pi over 2 is not in the domain. So I cannot use that. That cannot be an answer. Number 26, when is the sine equal to the negative square root of 2 over 2? And you're going to say that's going to be negative pi over 4. And what is the sine of negative pi over 4? And you're going to say negative square root of 2 over 2. So normally, if they're inverses, you can cross them out. But you have to be careful in cases like this where the domain is not met. So you have to watch out for that. Okay, these ones, find the exact value of the composition, leaving answers in radians, using triangles to help you. So I'm going to use a triangle for every single one of these. So when I have the cosine is 4/5, what I'm going to do is I am going to draw a triangle. I am going to put this angle here. And then the cosine, if the cosine was 4/5, that means the adjacent side would be 4, the hypotenuse would be 5. So this basically gives me this triangle, and now this is all theta. Now I'm going to ask for the tangent of theta. Well, to do the tangent of theta, I need this opposite side, so I would do 5 squared is equal to 4 squared plus b squared. This ends up being 3, so the tangent of this angle will be 3/4. So what I'm doing is I'm first drawing the triangle, and then I'm answering the question. So inside the parentheses, that's telling me how to draw the triangle. So again, I'm going to draw every single triangle basically the same way. I'm going to put theta here. The tangent is going to be the opposite over adjacent, so I'm going to have 5 over 12. Doing the Pythagorean theorem, I'm going to say 5 squared plus 12 squared is equal to b squared, and then this ends up being 13. So now when I find the sine of this angle here, because this now is theta, when I find the sine of theta, that's going to be 5 over 13. Okay, arc sine is -8/17. Again, drawing this triangle, don't really care what quadrant it's in. I'm going to figure that out later. The opposite would be -8. The hypotenuse would be 17. Doing Pythagorean theorem, I'm going to find out that that missing adjacent side is 15, I believe. So now when I go to find the cosine of this angle, because remember this is just telling me how to properly draw this triangle. So now to do the cosine, I'm going to have 15 over 17. And there's some logic that goes through this. Arc sine That technically has to come from the fourth quadrant. The cosine of an angle in the fourth quadrant is going to be positive. That's why this is positive. Okay, number 30. The cosecant is negative 13 over 12. So again, drawing my triangle, the cosecant is negative 13 over 12, which means the sine is going to be, the sine of that angle is going to be negative 12 over 13, the reciprocal. So the opposite will be 12, the hypotenuse will be 13. Doing Pythagorean theorem, I'm going to find out that this missing side is 5. Again, this is coming from the fourth quadrant. And now when I go to do the cotangent is the adjacent over the opposite. So that's going to be 5 over 12. Using the same logic, this 12 was a negative, right? Because the hypotenuse can never be negative. I can think of it that way, or I can think of, again, this is coming from the fourth quadrant. The cotangent is negative in the fourth quadrant, which makes this answer negative. You got to kind of use that logic. Oh, I'm going to have to skip up to 33. I know I'm skipping 31, 32, but I promise I will do those. Okay, this one, when is the sine equal to a negative square root of 2 over 2? Well, that's from my unit circle, so I really don't need to draw the triangle. That's going to be negative pi over 4. And what is the tangent of negative pi over 4? That's going to be a negative 1. What is the cosine of pi over 3? Well, that's going to be 1/2. What's this? When is the sine equal to 1/2? That's going to be pi over 6. If they're on the unit circle, no triangles necessary. No calculator either, though. Arc sine, when is the sine equal to pi 1? That's going to be pi over 2. And what is the tangent of pi over 2? Well, remember, tangent is sine over cosine, so that's going to be 1 over 0 at that point, which means that this is going to be undefined. 36, arc cosine is equal to 1/2. Well, the cosine is equal to 1/2 of pi over 3. And then the secant is a reciprocal of cosine. So the cosine of pi over 3 is going to be 1/2, which means that the secant of pi over 3 is going to the reciprocal of that, which is 2. So that answer is 2. Okay, going on to 31. Again, not on the unit circle, so I am going to draw a triangle. Putting the angle here, cosine is adjacent over the hypotenuse, and it wants the secant, and the secant is 1 over the cosine. So I don't even have to find the missing side. I'm just going to take the reciprocal of this and write 3 over 2. The cotangent is equal to 4. So I'm drawing my triangle. Cotangent is the adjacent over the opposite. So I can think of this as 4 over 1. When I do Pythagorean theorem, 4 squared plus 1 squared is equal to that hypotenuse squared. This ends up being the square root of 17. Now it wants the sine of this angle, because this now becomes the angle. The sine is 1 over the square root of 17. 1 over the square root of 17. Rationalizing, I'm going to have the square root of 17 over 17. 37, the sine of 7 pi over 6 is going to be negative 1/2. And then when is the cosine equal to negative 1/2? That is going to be 2 pi over 3. And then the last one, cosine of negative 7 pi over 3. Don't really like that, so I added 2 pi, and I get the cosine of negative pi over 3. That's a coterminal angle, which tells me it's in the fourth quadrant, which tells me my cosine is positive. So this is going to be the inverse sine of a positive 1/2. So when is the sine equal to 1/2? And you're going to say pi over 6. So that's how I do those ones. Now the next ones, I am going to have a triangle drawn for me, and it's going to want me to find the angle that's missing. So I'm looking for this angle here. I have the adjacent side and the opposite side. So I'm going to say the tangent of theta is equal to the opposite over the adjacent. I like to write that first, but you really don't have to. You can just skip right into theta is equal to the inverse tangent of 27 over 38. Remember, when I'm looking for the angle, I'm always going to do the inverse of the trig function. So when I first put this in my calculator, it told me theta was equal to 0.62, rounded to the nearest hundredth. So I'm going to change that to degrees, and I'm either going to multiply by 180 and divide by pi, or hit the DD button on my calculator, whatever makes you happy, and I'm going to get an angle of 35.4 degrees. But this is the answer that I'm going to see first on my calculator, and that is right. I just have to change it to degrees. Okay, this next angle here, I have the opposite and the hypotenuse, so I'm going to say the sine of theta is equal to the opposite over the hypotenuse. So writing that as an inverse, I'm going to say the inverse of sine. I know 40 over 42 can be simplified, but I'm probably not even going to take the risk of simplifying it. I'm just going to put it in my calculator the way it is so I don't make a mistake. When I do this, I get theta is equal to 1.26 rounded to the nearest hundredths. I'm going to change that to degrees and end up with 72.2 degrees. The next one, I'm looking from this angle here. I have the adjacent hypotenuse, so I'm going to say the cosine of theta is equal to 4 over 5. So theta is equal to the inverse cosine of 4/5. That looks like a 5. When I do that on my calculator, I get 0.64. And I'm going to change that to degrees, which ends up being 36.9 degrees. Okay, number 42. I am going to look at this triangle. I'm looking from this angle. I have the opposite and the hypotenuse. Remember, the hypotenuse always is opposite of the right angle. So I'm going to say the sine. I'm going to skip the sine inverse if you're okay with that. The sine inverse of the opposite over the hypotenuse is equal to theta. And when I do that, I get theta to equal, on my calculator, 0.52. Which is going to be 30 degrees. I'm wondering if any of you realize that that sine inverse, if I were to simplify that, that was 1/2, which should make sense to you that the sine is equal to 1/2 at 30 degrees. The next one, I'm looking from this angle here. I have the hypotenuse and the adjacent, so I'm going to say the angle is equal to the inverse cosine of the adjacent over the hypotenuse. And when I do that on my calculator, I get theta is equal to 0.72, which will be 41.4 degrees. And finally, the word problems. So this one, the sonar of an Asia cruiser ship detects a submarine that is 5,000 feet from the cruiser. And they're showing you that this is what they mean by the 5,000. It's going to be that diagonal line. The angle between the water and the level submarine is 32 degrees. So this angle right here is 32 degrees. They want to know how deep the submarine is. So, well, I can just draw this triangle right here. So, and I'm just going to pull that out so I can see it. Well, maybe I won't. So my triangle will look like this. So this was 32 degrees. This R we said was 5,000, and I'm looking for how deep my submarine is. So I have this angle here. I have the opposite and the hypotenuse, so that's going to be sine. So I'm going to say the sine of 32 degrees is equal to the opposite over the hypotenuse. And when I do this, I'm going to end up taking the simplify, multiplying both sides by 5,000. So I'm going to take 5,000 times the sine of 32 degrees, remembering to put that degree symbol into my calculator. And when I do that, I'm going to get x to be 2649.6, and that'll be feet. So 2,649 feet. To do the next one, from a point on the ground, the angle of elevation to the building is 27 degrees. So they're telling you that this angle here is 27 degrees. The distance to the base of the building is 45 meters. So this is 45. So here I like to be big. This is 45. This is 27. And they want to know how many meters high is the ledge. So I'm looking for this side here. I'm looking for the opposite side when I have the adjacent. So that's going to be a tangent of 27 degrees. The tangent of 27 degrees is equal to the opposite over the adjacent. To solve for this, I'm going to multiply both sides by 45. When I do that on my calculator, I'm going to get 22.9 is going to be x, and my units are going to be meters. So 22.9 meters tall is the ledge. The next one, a laser is placed at a distance of 47 feet from the base of a building. So here's my laser, 47 feet. Here's my building. This forms my right angle. It says the base of a building that's 23 feet tall. So this is 23 feet. What is the angle of the laser, presuming that it is at ground level, in order to point to the top of the building? So here's the top of the building. I'm looking for this angle right here. So the sides that are involved are the opposite and adjacent. So I'm going to say the tangent of theta is equal to opposite over adjacent. I'm looking for an angle, which means I have to do the inverse function of 23 over 47, and that's going to give me my angle. When I first put this in my calculator, I get theta to equal 0.455. And in degrees, it's going to be 26.1 degrees, and that's going to be my angle of elevation. And finally, the last one has a radio station was built in two sections from a point 87 feet from the base of the tower. The angle of elevation to the first section is 25 degrees. So I'm going to draw a separate triangle for that. I know it's over here, and this is the triangle that I'm drawing right here. Wonder if I do, oh, I can. So that's the triangle that I'm drawing right there. So get this guy out of the way. This is my right angle. This is 25 degrees. And they told me that it's 87 feet away. So that's that fun. That's that first one. I don't know what just happened. Okay. Oh, that was scary. So that's going to give me to here, which for lack of anything else, I'm going to call that A. So I'm going to call that height A. Then they tell me that from the same point, if I look up 40 degrees, I get to see the next part of the station. So if I look from here, so from here, now I'm looking up 40 degrees, and I'm going to see the top part. So if I do that, this is still 87 feet. This is 40 degrees, and for lack of anything else, I'm going to call this B. Notice if this is B, and this section's A, then to find X, I'm going to say X is equal to the B minus A. So I'm going to find the height of the tallest section and subtract the height of the smaller section, and that should tell me the difference between the two. Both of these have opposite, oh, this is feet. Both of these have opposite and adjacent, so I'm going to say the tangent of 25 degrees is equal to, I called that A over 87. I'm going to multiply both sides by 87. And when I do that, I'm going to get A to equal 40.57 feet. Then I'm going to do the same thing for this one. It's also going to be tangent. I have the opposite. So the tangent of 40 degrees is equal to opposite, which I called B, over adjacent, which is 87. I'm going to multiply both sides by 87. And when I do that, I find out that B is equal to 73. And I got 0.00, so I'm going to keep that 73 feet. So to find the X, I'm going to take 73 and I'm going to subtract that 40.57, and I'm going to end up with a difference of 32.43 feet. And so what that's telling me, going back up to their picture, is the difference between this distance from here to here is going to be that 32.43 feet. All right, well, I hope this helps, and we'll see you next time in class.